right, so this is the last little bit of 4.2, and this is an application of asymptotes, really. So this is finding a minimum area, and there's a couple of ways that we can approach this. So, like if I gave you a
Okay, I finished, Mr. Shadewell.
square,
That's a rectangle.
if I gave you a rhombus,
That's a rectangle.
It's a rectangle with a kind of rhombus.
Or is a rhombus a kind of rectangle?
I will struggle.
Whoa, guys. That's not very kind of you. Let's take it down a notch.
And I don't care.
No. That's
But
not.
being nice is important.
Sharing
Now
is
when it's like
caring.
nothing but shit from other people.
Sharing is caring. My grandma.
wow, look how good that looks.
It's
It's
spectacular.
Look how amazing that
Oh,
that is.
color
Too bright?
combo.
Too bright?
My grandma once told me.
I can make this one brighter.
What you put into the world is what you get out of the world.
How's that?
Blue, make it blue.
It's
How's
like
that?
those candies, you know,
Hey,
the yellow and
Yellow
the
and purple. No,
Yeah.
no, keep it.
Oh my
Wait,
God,
it's
it's
the
the
geometry
geometry
dash.
dash.
Yeah, I like that.
No.
No. No, I like the brighter blue.
Dude.
Yeah.
All right. So we have a this is a page with a printable area. Forty-eight 48 square inches.
I'll take that as a yes.
Mr. Shadewell,
Yeah.
what is the first word?
Rectangle. It's the first word is
Ah.
So I'm gonna have up at the top and bottom. I'm gonna have 1 inch of margin. Hmm. Okay, so I'm going to set up a formula for the area of the rectangle with these margins. So the margins are fixed. I need 1 inch of top and bottom margin, and I need 1.5 inches left and right, and I need 48 square inches of printable area. That's the blue area. But I can make the rectangle more square. I could make it wider. I can make it narrower. I can play with these dimensions. So, so here for the x, the width of the printable area, I'm just going to call that x, and the vertical dimension I'm going to call y for the printable area. And so I need a formula for area.
X times Y.
Yeah, we can start with the formula for the printed area. So the area for the printed part is what? Equals x times y. So, but the area for the page,
X plus.
wait. You write it down. So I'm gonna come around and I'm gonna see what you come up with. So I need a formula for the total, like the whole page, and then I'm gonna ask you to do that, and then I'm gonna have you do in terms of one variable.
What does that say before terms?
In
Oh.
So I'm gonna do an area of the page in terms of one variable. What is the area of the printed part, by the way?
48
48.
inches.
Where's the printed
Where?
part? The blue part or the yellow part? Or the total?
The 48 inches is the blue part. That's the printable area. The margins are the yellow part. So this is the formula for the blue area. The area of the printed area of the printed part is 48 square inches, and it's x times y.
Okay.
Now I want you to write a formula for the whole page, and you can do it in terms of x and y, and then I need you to do it in terms of just one variable.
No.
Yes, you do.
I know. Wait, will you look at my Mr. Show?
So that's a area,
And now you want me to do it with just one variable?
and now I want you to substitute out and use just one variable. Now, so do you recognize that I have some options here? This doesn't have to be, you know, the overall dimensions don't have to be 8.5 by 11, or doesn't have to be any size. I can make it whatever size I want, as long as it's 48 inches for the printable blue area, and I have these margins as well. So x right now is still truly a variable. How wide do I want it? Y, how tall I want it, is also a variable. So I need a formula for the area that lets me play with those numbers. So I need an area for the printed part, or for the overall page, I mean, that includes x and y. Do you see that this includes x and y? I don't know what x and y are yet, but when I multiply them together, I have to get 48. So what's a formula that I can use for the overall page in terms of x and y?
So the formula you can use for the overall page would be like fx equals.
I'm saying a.
So just a equals.
It's just a equals, and I did two areas, so I put a subscript. So it said a area for the printed part and area for the overall page. A sub printed and a sub page.
Should we look at my options?
Mm-hmm. Everyone stuck on the substitution? I mean, yeah. That's not what I need. Not what I'm needing you to do right now, though.
What do you want me to do?
I'm wanting you to. So you did the A sub page, and now I want you to express like your A sub page is in terms of two variables, right? What do you need to do to get it in terms of one variable?
Subtract y.
No.
Wait a minute, wait a minute, wait a minute. Silly.
Y equals
You got beautiful answer.
48.
How wide is what's the overall formula for area of a rectangle?
Wait.
Yes.
Length equals.
No. Area equals
Oh, area equals length times width.
area equals length times width. What's my overall length here?
1 inch.
What's my overall length here for the whole page?
X plus 3. Yeah.
Oh, yeah. I get
What's
it.
my overall width?
Y plus
Y plus 2.
Yeah.
Got it.
Okay, so we have that so far.
Then I have an equation to get y, but
Does everyone have x plus 3
Yeah.
times y plus 2? That's a formula for the area in terms of two variables. What do I have to do to go from two variables to one variable?
find an answer for y. Or
Substitution. What kind of substitution can I use?
You could do like.
Can I express y in terms of x or x in
Yes,
terms of
yeah.
y?
Yes, that's what
How?
48 over x.
So in place of y, I can substitute in 48 over x.
Yes.
So now what does that make? What does that do to my formula for the area?
I just got the word of
x plus 3
Yeah, x plus 3,
times 48 over x.
48 over x plus 2. And is this in terms of one variable?
Yeah.
So if I'm asking you for a formula in terms of one variable, you could stop there. You could stop there. But for the purposes of this example, let's go ahead and simplify this a little bit. Let's bring out the 1 over x. So can I factor out a 1 over x and write this? Like, can I bring this x to the denominator? How do I factor out? Let me not do that step yet. I'm going to do that step in a second. How do I factor out a 1 over x?
That would come out to x plus 3, 1 over x, 48 plus x 2x.
Okay, does everyone see that?
So you're essentially multiplying 3 by x.
Mm-hmm.
Mathematically simple.
Right? So how do I write my formula in terms of something over x? What do I have left, Cormac? I'm going to write that x in the overall denominator. That leaves what?
X plus 3.
X plus 3,
48 plus 2x.
48 plus 2x. Right. Right.
So, okay.
What happened?
So can you multiply those right now?
So now I have a formula
Yeah, okay, this makes sense.
for x, for area in terms of one variable, and now I want to minimize this. So this ends up being something that I can put into a table if I want to on my calculator, or I can put it on a graph, and I can look to see where that minimum is. Yes. What happened?
Why do you plan? Like, I see why you can apply x over the whole thing, but like, why can't you do that? Like, I see how you did it, but why can't you?
What do you mean apply x through the whole thing?
Like, divide everything by x.
That's where this 1 over x was. So this was, like, if I move this to the front, then this is 1 over x, x plus 3, 48 plus 2x. You okay so far? And then do you agree that those are equivalent?
Yeah, but how does it become 2x? From
because
48 over
I'm taking out the 1 over x. So if I put the if I distribute the 1 over x back in, what does this become?
48 over x.
If I distribute it here, what does this become?
2
Plus 2x.
2. Huh?
Why
Huh?
is it
What?
Plus 2x.
No.
Plus 2.
Right.
Yeah.
Because it's plus
That's
two
what I
x
said.
over x.
I needed it to revert back to what it was before I factored it out.
Then why does it also apply to the x plus 3?
Why doesn't it apply?
But why does it apply to x plus 2?
It doesn't apply. I didn't factor anything out of the x plus 3. I have this is a times b times c, and then I'm saying, well, I'm going to rewrite it as b times a times c.
Then why is x plus 3 over x on the bottom, like the thing below?
On here,
Yeah.
why is it there?
Yeah.
Because 48 plus 2x times 1 over x times x.
Would you agree that 2 times 3 times 1/2 is the same as 2 times 3 over 2?
Yeah.
Yes?
That's what he did.
Wait.
That's what I did.
2 times 3 would be 6 times 1/2 is yeah.
2 times 3 is 6 times 1/2 is 3. 2 times 3 is 6 divided by 2 is 3.
Yeah.
Yes.
That's essentially what he did.
Okay.
Right. This thing, if I have a fraction out front here, it's the same as writing it over the entire thing, because these things are multiplied together,
Mm-hmm.
separate from the fraction. Just like here, they're multiplied together, separate from the x in the denominator.
Okay.
All good?
Yeah.
So I'm sort of done setting up my function. Now I can use my function in my graphing utility or my table. So my graphing calculator is going to help me.
Right now.
I'm telling you how to do it, and you're not listening.
I'm trying to write it down, sorry.
So let's do that.
Done.
You did it.
Yeah, my lead was breaking like every time I try and write it, and it's
You've gone on and found the minimum area.
no.
That's what you weren't listening to.
Yeah.
You were doing something else. So let's do that. Let's see. I'm gonna pull up my TI-84. So you can be doing this too. Where are your calculators?
On the telephone now.
By the way, while that's doing that, I need to find my domain of my function. Like, could I choose any value of x for this function?
Yeah, technically.
Yeah.
So
No,
that's where math departs from physics. So math-wise, as long as I don't use x is 0, this function works in the math realm, but it doesn't work in the physics realm. It doesn't work in reality. So if I have an x times y and I need that to equal 48, then there's somewhere that doesn't work anymore. Like, can I choose like what values of x can I choose?
Well, I mean,
Reals.
no, not specifically reals, because eventually you could hit to the point where if x is too great, then y would have to be so small to balance it out that it would essentially be impossible to fabricate in reality. So, the first thing I think of is 96 for x and then 1/2 for y, just as like a more extreme one, but probably the most common would be 6 and 8.
So I like a middle value, like randomly choosing 6 times 8 to get 48.
Yeah.
Is that what you're saying?
Yeah.
Or even 8 times 6 possibly could work too. But there's going to be values that are too small or too big, right?
Yeah.
So, and we'll probably see that on the graph. So, so you can take your choice. Do you want to do it graphically or in a table?
Graphically.
You see it graphically first? So how do I do this graphically?
Open decimal and time.
No, I'm gonna do it on T84.
So you hit graph and then window, I believe.
So I'm gonna look at graph and see if there's anything there, and I'm gonna hit zoom 0 to get to my standard. No, that's zoom fit. So I'm gonna hit zoom 6 to go to my standard -10 to 10 and -10 to 10 on X and Y. And I can verify that by saying by going to window and seeing that now that I hit zoom standard, this gave me this window from X goes from -10 to 10 and Y goes from -10 to 10. And I'm gonna click, what else am I gonna do to get my graph up there? How do I graph?
Y input.
Yeah, so Y equals, and I'm gonna clear this because I don't want that graph on there. And then what?
You input your equation.
My equation is what?
X plus 3 times 48 plus 2x.
So if I just type X plus 3, I'm gonna have a problem. X plus 3. What do you want my times to look like?
It has to be times that entire thing, so it has to be in parentheses.
So I need parentheses first. So I'm gonna hit parentheses, and then I'm gonna hit X plus 3, and then close parentheses,
Yes.
and then
Open parenthesis, 48 plus 2x, close parenthesis, divided by x.
divided by X. Right. And I can graph that. Now, what am I gonna do to try to get the graph to look nice? Zoom out. Is there a way that I can try to get the calculator to give me a nice window automatically?
Change it. Do I change the size of the window?
How?
Well, I put the zoom standard.
Zoom standard is what I already did. Zoom standard gives me -10 to 10, so I'm already,
If you
I
go
don't like
window,
that.
right?
What about zoom fit?
Zoom fit, yeah.
If I do zoom fit, which is zoom 0, then that lets it try to give me a scale that I can use.
Yep.
Right.
So
Oh. It was a matter of perspective.
So let me try. So I don't care about the negative values of X because that doesn't make sense, right? So that's outside of my domain, right? So I'm going to say for window, I'm going to say X is going to start at 0 for the minimum value. And let me just look ahead to see what else it might be on there. So I'm going to go out to 100. And then Y, it doesn't really help me for a negative value for X, for Y either. So I'm going to say 0 here. And I guess I'll just leave the rest alone. So let me try graphing it that way. All right, do we see that as far as minimum area, there becomes a sort of an area that we're interested in here?
Yeah.
So this is a formula for area, right? So I have a larger area over here and a larger area over here for these dimensions, but for minimum area, I'm interested in this part. So how do I find out what that value is in TI-84?
Go to trace.
Trace. I'm going to go to trace, and I'm going to scoot over to that. So my X value is like 50 and less. There's 30. There's 20. There's 10. So I'd like to zoom in on this a little bit and just do X from 0 to 10. And now if I hit trace again, then you see the Y value. Let's see, Y value is going down, down, down,
Also,
down,
if you
down,
go to
and now it's going up.
Go to calc and to get an even more precise answer. Just second and then trace. Okay.
So okay, so first of all, wait a minute. Let me do a window from. I'll just cut the y in half. So let me just do up to 500, and then max maybe I'll do 15 here. And with trace, do you see what I'm doing here on trace? I'm hitting left and right for my x value, and you see the y values it's giving me, and I want the minimum area. So this would be area of 162. This would be area of 93, and you see the areas going down to 85.321, 88. 88.0.
The most precise answer, Mr. Zhou.
Yeah. So somewhere in here in this region for x values is going to be my minimum y value. All right, let's do calc.
I got one that's 87.941.
Okay, I'm about
Yeah, I
there.
got 87.9411.
And then you did that by doing what?
Second and trace,
Second trace gives me my calc option,
then minimum,
and then I want minimum. I'm trying to find the minimum,
and then you give it left and right bound.
and then as long as I'm left and right of my final area, it will tell me where the area is. So I want to make sure that my values are going up here, which they are.
Oh, and then yeah.
That doesn't matter what the guess is.
And then I press enter again, and then it gives me what are these values telling me? So I'm going to write this down. What are these values telling me? I've done the work on the calculator, but what does this mean? How can I use this?
The x value is the minimum x, and the y value is the minimum area.
So x value says 8.48, or let's say 8.49, and the y value is what?
87.94113.
87.94. All right, let's go back to our paper. What and how do I report this as my answer? Like, what is the question asking for?
Min x and min y.
So let's look again at the way it's asking the question.
What should your dimension be to use the least amount of paper?
Right. How do I report my dimensions? How do I answer the question? I've done all this work. How do I write down my answer?
It would be x equals 5.49.
No.
5.657.
What is it?
5.657.
No. Where are you getting that?
Oh wait, that's
No, y. That's the area. The one on the right is the area, not the y value.
Yes, that's right. You're right. So this, yeah, it was telling me the x and y on the grid was my x dimensions and my area. Good job. So this was the area of the what?
The big square.
Which is which one?
the paper as a whole.
It's the page. It's the whole page, right? It's not area of the printed area, not the area of the printed region. So,
Wait, is it asking for the dimensions of the printed area or of the page as a whole?
oh, this is very important. This is a very important area of interpretation, right? So I have a rectangle, and then I'm saying all the stuff that I'm talking about the rectangle, the printed area has to have this area. The margins are this. Set up a formula. So this is all stuff that I've been doing. My customer that's come to me, or my client, or my boss that's come to me and said, I need this page with this. What dimensions should we choose to have the minimum amount of paper being used? How
Page.
It's the whole page. It's the whole page. So you sometimes when you're reading a problem like this, you have to interpret what they mean, what they're looking for. So what is my
Wouldn't the least amount of paper just be with no margins? Wouldn't the least amount of paper just be with no margins?
That's answering something that's outside of what's being asked does not help us. So I have a piece of paper that needs left and right 1.5 inch margins, and I need top and bottom 1 inch margins. So no matter what my dimensions are, that yellow area is going to kind of
the
go along.
margins have to be there, but they're also
Yeah.
trying to figure out what size page would.
What size paper should I be using to have the minimum area, minimum amount of paper? So I have, like, what do I have so far, and what does it mean, and how do I find my minimum, like, how do I report my size of paper? What do I have? What does it mean? What do I know? And how do I report it?
What we have right now is the length of each side of printed paper that would lead to the least amount of margins, like.
Which is what?
Which is x equals 8.49 and or y equals 87.94.
This is my mistake calling this y before.
Okay.
That formula that we put into RT84 gives us area. So on that graph, it was x versus area.
So now we need to put 87.94 on the other side of the equation, and then plug in 8.49 for x, and then
Not
solve.
necessarily.
You just divide 48 by.
Y equals 48 over x.
Well, I thought 87.9 is the total thing, not the printed paper.
Well, yeah, that's the total thing, but we can just use the x. Just do y equals 48 over the x value.
Yeah. So in a sense, we can ignore what our area of the printed page was. We don't really need that so much. We have enough other stuff to get there.
Oh.
So I don't really care what the minimum area of the page is. Like if they, I mean, we can double check that the dimensions that we want to choose give us that area, I suppose. But we're not going to really use that to calculate it. What is my y for the minimum?
5.657.
Tell me how to find it, not what the
Oh.
answer is.
Y equals 48 over x.
Right, it's 40. So x and y always have this relationship, right? So it's x and y is always 48, or y is always 48 over x, right? So what is 48 over x?
It is 5.657.
5.657.
Yes.
Okay. And what are these things? What are those things? Matt, what's x and y there?
Those are the dimensions.
What?
What's the
Matt?
formula for
Oh,
the
sorry.
printed area?
It's not the formula.
It's the variables for the printed area.
Yeah, it's the dimensions of my printed area. But are they asking me for the dimensions of my printed area?
No, they're asking you, yes, no. What dimensions should be used to use the least amount of it?
Mm-hmm.
Because we know those two are good.
Dimensions of the whole page.
I want the dimensions of the whole page. Right. So I started talking about the rectangle, and then all this stuff is like details about what property should the rectangle have, and then I say what dimensions should I use to use the least amount of paper. I'm still talking about the rectangle. So what's my overall width dimension, Baron?
Your overall width dimension should be. What you call it? So 3 plus 8.49, so 11.49.
And Cormac, do you want to do the length?
Yeah. It's gonna be like 7.66.
Don't give me the answer. Give me how you did it.
7.6.
5.66 plus 2 equals
Fan.
a
Cool. Oh yeah, 7.66 inches of length. Can't forget your units, Mr. Shale.
Be inches.
In. Always gotta remember the units, otherwise you'll dock our points.
Indeed.
Mr. Shade, I have a question for you.
Mm.
It's a little off topic, but
Mm.
how hard is it to program like a VR game?
A little bit off topic.
A lot off topic.
Very difficult.
Like, how would you combat that? You know?
So there's a way to do this in tables. So you can put the formula in, and then you can construct the table. But you're still going to be estimating those jumps on the table. So putting it into a graph and then using that calc to find the minimum gives us the most precise answer. Because even going left and right on trace gave me an idea of where that minimum dimension x should be. But the calc one was the one that really narrowed it down. So that's really all there is to that. That was all there was to that question. Huh?
We back up or we still?
No, you don't pack up. Oh, you got 4 minutes.
We've been time 4 minutes. We
You
could
got
do
4
so
minutes.
much
You could
learning in 4
do the
minutes.
homework. You
It's
could
a
work on
Friday.
4.2 homework.
It's a Friday, Mr. Shade. It's a fun day Friday.
I'm so tired.
Yay, but dude.
I'm ready. I have another one tomorrow.
So,
Funny corner.
Chapter
Thank you,
4
man.
review for before the test on Tuesday. And the chapter 4, huh?
This will be on the test on Tuesday, right?
You better believe it.
Okay. You recorded this, right?
I did.
So if I get really confused,
Or did I?